The webinar is about sustainable cities and technical innovation. And it's a really great pleasure to welcome you here today, along with my colleagues. I have two colleagues here. It's David Leipziger and Miodrag Grujić. We'll be discussing the role of cities when it comes to climate change. Cities, as you know, are very significant waste producers, significant energy consumers, and transport users. And cities are some of the biggest contributors to national carbon emissions, directly affecting or even setting the agenda of emission profiles in a country or in a region. But there's massive potential as well with cities, and we're going to be talking about that in this webinar. I know many of you already, but if you haven't met me, I'm the founder and visionary here at ECO. I have over 23 years of experience creating markets in the sustainable energy and climate change sector in developing nations and in emerging economies. I set up ECO back in 2000 and have been working to identify opportunities and barriers from technical and financial standpoint, from knowledge, capacity, all these different elements to identify framework conditions related to policies and these institutional conditions to address climate change and bring us onto a more sustainable path, including some of the work in cities. ECO is an international climate finance and development consultancy. We're really uniquely specialized in the design of initiatives. These could be low carbon, climate resilient projects and programs. And for over 23 years, our team of specialists have been providing technical expertise to help our clients, potentially you, to solve climate adaptation and mitigation issues and other development issues. We devise projects that have a greater impact and a greater funding success. This year has been really exciting for ECO as we grow our consulting team, expand into territories where we're based, and expand our specialisms. Once again, please, a very warm welcome to you, and do introduce yourself in the chat. It's really nice to hear from you, to get greetings there. Please do feel free to introduce yourself in the chat. Right, let's get into the details. In this session, we'll be covering several key topics. These include what cities are doing the most, or perhaps the least, to address climate challenges. What are the constituent components of a city's climate footprint? How can digitalization be used to address emission problems? That's a fascinating, new emerging topic in which we have a whole lot of experience. What technical innovations are available to use? And how can cities be both the problem and potentially the solution? Please do participate as we go along. To do that, you can post comments in the chat. You'll see there's also a tab called questions. It's got a question mark above it. If you click on that, you can type in a question and we'll try and address them as we're going, or at a Q&A point along the webinar. Do please also participate in the polls. We launch polls every now and then, integrated into the presentation. We'd love to hear your voice and your thoughts on this, so that you can get the most out of it, and so that we can be very responsive to who's participating in this. So submit your questions as we go, and also you can upvote them on that aspect of it. And yeah, we'll be sending out a webinar replay kit. That's quite important. We always get, the first question is, will I get the slides? Will I get the recording? Yes, the answer is that. And we'll also try and answer some of the questions in the longer term. So let me start off by introducing David to you. David Leipziger is an expert with 15 years of experience in sustainable urban development, with significant experience in cities such as Nairobi, Mexico City, Bangkok, and Baku. So really a broad international experience. He's published research on climate finance, on low carbon transport and land value capture. and has served as the Chief Urban Mobility Expert at Innovate UK. So, David, over to you. Looking forward to your presentation.
Thank you very much, Grant. And hello, everyone. Hopefully you can hear me. And if there's any issue, let me know. But I'm really delighted to talk about the topic that I am most passionate about, which is sustainable cities and how urban areas intersect with the climate crisis and climate change. So it'll be mostly a sort of mitigation story, but there are also components of climate adaptation and resilience. And I'll do a quick expanding on my intro just to give a bit more flavor, to say that I am an American. I'm coming to you from London, however, and I've worked in many different parts of the world, as Grant alluded to. And I've also worked in both the public and private sector and focused on buildings and transport mostly, and supporting low carbon policy, technology, and infrastructure delivery. So that's sort of my frame of reference. And I'll take you through the agenda for what I'm going to speak about. And then after that, Miodrag will follow with maybe a more practical and tactical explanation. So I'll spend some time speaking to why we should care about cities and climate and the interactions that explain them, and then dive more deeply into the different sectoral contributions to urban emissions. And that includes buildings, water and waste, transport, food, and green space. And subsequent to that, I will turn it over to Miodrag to talk more specifically about how technology and tech innovation really are borne out in urban areas when we are considering actions to combat climate change. So in the process of my chat, I'll have a couple of polls that pop up, and feel free to make any comments in the chat. There's also a questions tab below on your screen below the conversation, and feel free to put any questions in there. And please do respond to the polls. It's no one will know if you get it right or wrong. It would be great to have you participate. So without any further ado, I will dive in. So why are cities such an important contributor to and topic in the climate change discussion? Well, if we look at the vectors of global greenhouse gas emissions, it's pretty obvious that energy is the most common contributor. But if we expand on what that means, the large chunks of contributing emissions are things like industry, transport, and buildings. So aspects of the built environment that, lo and behold, are suspiciously present in urban areas. So it's true that that most of these sort of energy emissive vectors are found in urban areas. And that's why we can say with relative certainty that there is a correlation between urbanization levels and emission intensity. So in this graph, each dot is a country, and this scatter plot shows the urbanization rate as it impacts the emissions intensity of given countries, and the correlation, while not totally explanatory, there's a clear correlation, and it's a superlinear one. So the more urbanized you get, the more and more, the more emissions you create at an increasing rate. So the degree of urbanization in a country is definitely important. So we've reached our first poll. I'd like to know if you can guess what is the proportion of global energy consumed by urban areas, and also what is the proportion of greenhouse gas emissions that are to which the top 25 cities contribute. So I'll give you a minute to reflect on that. We're interested in what is the percentage of global energy consumption that cities are responsible for. And then subsequent to that, all right, we've got some good guesses. congregating around 75. Some people are thinking 52. Just one person is on 26, which is unique. And then what's the proportion of global greenhouse gas emissions that just the top 25 cities produce? So if we just look at the 25 most emissive cities, the ones contributing the most, what is the proportion that they're producing? So there's a logic here. It won't be larger than, or it's unlikely to be larger than the previous one. All right, so we're in similar territory, and I think the wisdom of the crowds may have had it, but the punchline is that 75% of global energy consumption is the domain of cities, and more than half of emissions are produced by just 25 cities, which I think, even as a person who works in this domain area, is surprising to me almost every time I reflect on that. So just 25 cities are responsible for half of greenhouse gas emissions. So this represents a significant challenge, but it also could be a great opportunity. There are a small number of places that are producing a large number of emissions. And on a global scale, the places that are producing emissions are depicted in this graph, or this map rather. And on a per capita basis, we're seeing a lot of emissions coming from North America, Russia, Saudi, Australia, and a couple of other places. And what I think is important to note about the distributions on this map is that if we compare the climate change contribution of countries to the subsequent map of urbanization rates, it is perhaps unsurprisingly, it seems unsurprisingly well correlated. The places that are the least urbanized are producing the fewest emissions. This makes sense given the numbers from the previous slide. Where it gets perhaps more interesting is when we have a triple or a third layer on this, which is where climate impacts are going to be most severe. And this brings up important questions about climate equity, and intrinsic to understanding the sort of climate change and city nexus is the fact that the places that are the least urbanized and contributing the fewest emissions per capita are some of the places that will be most impacted by climate change and sort of future disasters. There's a question in the chat that I can address while I'm chatting, which is about distinguishing between urban areas and industrial areas. And I will say that most definitions of urban are essentially a question of density. So if it has less to do with land use and more to do with population density. So if there are areas that have very few residential or commercial individuals present, then that industrial area might not be considered urban. But in most cases, industrial areas are part and parcel of urban areas. Hope that answers the question. This question of urban equity is one that I just want to press on a little bit, which I think is very interesting to consider in global context. When we think collectively about what are the greenest cities, and indeed if you look up rankings of quote unquote green cities, you fundamentally see a list of what could be best understood as the most expensive cities in the world. It's almost always rich cities, your London, Paris, Zurich, Singapore, places that may have very high quality of life and are also very expensive. But actually, many of those rankings are not considering the total contribution to climate, rather more sort of policy action and quality of life. Whereas if we look at the cities that are contributing the least to carbon emissions, it might be a more surprising list on a per capita basis of places like Lagos, Dhaka, Karachi, Manila. And that's because, as the graph on the left depicts, the richest 10% of the global population is producing half of the emissions. So people in wealthy parts of the global north are contributing the vast majority of emissions, while a much larger proportion of people in the global south, in many of the cities that are on this list, are contributing much less. So I like to remind ourselves of this as an exercise in understanding sort of responsibility and attribution. So I'm going to talk a bit about the constituent components of urban emissions, and I will check the chat for anyone who can guess what this city is, and I'll give you a hint, which is that there's an American bias here. But anyone who has spent time in the American Northeast will recognize the frigid look of Boston, Massachusetts. That's the place that we're looking at in this photo. And the reason that I have chosen Boston is because it's an exemplar of a sort of rich world city, and there are two main typologies of urban carbon emission profiles, and Boston typifies one of them. And in the case of a place like Boston, if you look at the emissions inventory based on sector contribution, you will see in very small font that buildings are the most significant contributor. So in this graph, residential buildings are the darkest blue, commercial, institutional, and industrial are the teal, and then transportation is red. So in a city like Boston, and this would be true in my home city of London, and the city I grew up in, Washington, D.C., and many other peer cities, the building sector is really the main, is the plurality of contribution to their carbon footprint. The other typology is a city like this one. Any guesses from the chat what we're looking at here? Any Southeast Asians on the call? You might recognize the city of Jakarta in this photo, one of the largest cities in the world, and also having a relatively typical emissions profile to many cities in the global south or emerging markets, cities that are typically growing quite fast. And the emission profile of a city like Jakarta is the following, and the largest single contributing sector to emissions in Jakarta is the transport sector, which is the dark blue in this graph. So similarly, there are contributions from all of the following sectors, but in a place like Jakarta, transport emissions are more significant than buildings, and power generation is the second largest contributor. And there could be many reasons for that, and I'm happy to dive into it in maybe the questions or in future discussions. But I think useful to understand that there are several different but two predominant typologies here. So with that context, I'm going to talk about the subsectors themselves and their contributions to and centrality in climate change, particularly climate mitigation. So to start with the building sector, the main contribution to carbon emissions from the building sector, it really depends based on the energy source that those buildings are using, and is typically different in OECD countries versus quote unquote developing countries, for example. But typically in, as you would expect, colder countries, the heat will be a larger contributor, and in warmer countries, cooling, and the electricity generation is significantly where it's significantly dirtier, it will be a larger contributor. In building energy systems, the residential and commercial building sectors have slightly different energy use profiles. The end uses for the residential sector are typically led by heating and subsequent to that, water heating and cooling. In the commercial sector, end uses are typically more focused on plug loads and lights, but also subsequently on heating and cooling, depending on climate. But there are a variety of uses in buildings that really depend on use type and geography. But we'll hear some great specific references to how to increase efficiency and reduce consumption in buildings in the subsequent lecture. But these are the distributions of different end uses in residential commercial buildings typically, and their commensurate contribution to emissions. A critical concept in the building sector is the dichotomy between operational and embodied energy. So all of the energy that is consumed by a building when it's in use is operational. So using lights, turning on the heat, any appliances, that's all operational energy. Embodied energy is the energy that's created in the construction process of building a building. So the energy that's gone into creating the concrete that gets poured, the energy that goes into the transportation of materials to the building site, et cetera, et cetera. And in a typical building, the embodied energy will be somewhere between 25 and 10% of the total lifetime energy and emission profiles. But as buildings get higher and higher performance, in terms of operational energy efficiency, the embodied energy represents a more and more significant proportion. This concept of the embodied and operational energy balance is also very important to consider in future, with a sort of future lens. So as we're building more and more buildings, and as the embodied carbon, the embodied emissions might be proportionally larger than operational emissions because of geography, because of new technologies, and because of where construction is happening. Based on current projections, or at least projections from 2020, the embodied carbon of all new construction for that 30-year period will actually be much more balanced in favor of embodied carbon, which is to say that it's much more important whether a building is built and how it's built than how it's actually used, at least in relative terms in certain places based on these projections. So the concept here is that even though, wherever you're building a building or wherever buildings might exist, the embodied carbon and operational carbon need to be considered in balance, and any sort of urban policy or technology or investment program needs to consider this balance, and which is relatively more important and which has more longevity. So moving swiftly into the transport sector, which I may spend slightly more time on because it's more of my specialism, and I get more excited by transportation systems. The common concept here is there's a carbon footprint per travel unit or per travel distance of different travel modes. So cities that have a large proportion of high emissive modes have more emissions from the transport sector, and this graph is basically showing the carbon footprint of different travel modes on a distance basis. So the brownest way to travel is usually by domestic airplane or a domestic flight on an airplane, followed by petrol car. And the greenest ways are things like rail and electric vehicle, but even more sustainable would be non-motorized transport like walking and cycling. So the distribution of all of these of all of these mode types will create the composite for the transport emissions portfolio of a given city. And if you look at a given trip, you can calculate the emissions for a particular mode. If one were to travel, for example, from London to Glasgow, the most emissive journey for a single passenger would be by plane, and the least emissive would be, well, at least the least emissive of practical means would be by coach. If you want to walk or cycle that distance, I think that would be great, but you need a lot of time. So when you analyze the transport emissions footprint of a given city, you look at the composite emissions, and that's basically aggregating all of the individual journeys that are made, or rather assumptions about projections for the individual journeys that are made. And that gives you this comprehensive view of transportation mode share, which is the probably the easiest single metric to understand how mobility works in an urban system. So the typical, some typical profiles are given with these circles. So in London, which is the top left, you have a majority of travel done by private user, and probably roughly half of that, a little more than half of that, is private car. And similar profiles to that exist in cities like Seoul and Tokyo, which are all in the top row. So relatively comparable proportions of public transport, non-motorized transport, and driving, which is relatively common and a sort of median position. On the bottom, you have what are potentially more interesting and more extreme versions of transport mode share. So Hong Kong on the bottom right is one of the most public transport dependent cities in the world, or public transport rich cities in the world. The public transport system supplies roughly 90% of travel journeys. On the other side of the spectrum, you have in the lower center, Houston, which, like many car-dependent cities in the US and other countries, is almost the inverse of that. So roughly 90% of trips by private means, and most of those are private car. So the transportation emissions profile of Houston will be much, much higher than Hong Kong, just based on this, almost certainly based on this mode share graph. And then another interesting typology represented by Manila on the bottom left is much more balanced, I would say. And there is a fair amount of public, a fair amount of private. The use of private car is actually very small. And the single largest mode that is used by the average citizen in Manila is walking. And this is actually much more common than perhaps someone like me in a city like London would surmise. But a lot of cities in the global south and in emerging markets have very high proportions of walking. So Nairobi, where I lived briefly, has this is also true there. And many cities where the transport infrastructure is either incomplete or not necessarily favoring public transport, but there also is not the sort of willpower and wealth to invest in cars, for better or for worse. There is actually quite a high degree of walking, which makes for a very sustainable transport network. The relative efficiency of transportation modes is also important to consider from an urban planning perspective. So there really is a composite in terms of efficiency and emissions that urban planners need to consider. But I think notably for sustainable urban development advocates like myself, having mixed traffic, meaning sort of car dependent as default, is both the most emissive and the least efficient in terms of moving people per like area of transport corridor. And the trajectory to try and decarbonize the transport sector really depends on phasing out passenger cars, and particularly ICE vehicles, so internal combustion engines, and reducing the number of trips and shifting mode share away from those most emissive sources. I also want to point out that the transportation system in many parts of the world can be less formalized. I don't actually love the term informal transport, although it's common parlance, but popular transport is also is maybe preferable. But the prevalence of sort of small scale but pervasive private services providing transportation are actually extremely prevalent in many parts of the world, and often gets short shrift when considering how people move in cities. And then one of the final points about transportation is that it's in an urban context, it's one of the principal vectors of air pollution, and the preponderance of PM, so particulate matter particles in urban areas come from transportation emitting sources, and it's actually lower middle income cities and upper middle income cities, as shown on this graph, that have the worst concentrations of those. And there are various reasons for that, but an interesting distribution in terms of city typology. Okay, so talking about water and waste as another climate sector, WASH, water, sanitation, and hygiene, often is the acronym, and this is where we will step into our next poll of the day. So 2 more questions for you. First, if we aggregate together all of the global food waste that's generated, how would it rank if it were put alongside countries in terms of total emissions production? So all the food waste in the world, if it were a country, would it be the first, second, third, or fourth largest emitter of greenhouse gas emissions? Obviously it is one of them, so the surprise should be in the question. There's an enormous amount of food waste, and it creates a significant degree of emissions. And then the second question is related to water and water use. How many people in the world are regularly experiencing severe water scarcity? It is in the billions, folks. So is it 1, 2, 3, or 4 billion? So hopefully your votes are locked in, and I can give away the results here. It seems like, yeah, people actually got these right. The wisdom of crowds has prevailed again. Yeah, global food waste would constitute the 3rd largest GHG emissions producer if it were a country, and 4 billion people worldwide are suffering from water scarcity. So an important highlight to the importance of both water and waste, not just to climate mitigation, but also to climate resilience, adaptation, and general social justice on a global scale. So municipal waste, or consumer waste, is predominantly food, which is probably not surprising given that previous stat. The graph on the left demonstrates what the different component vectors of waste are from urban areas, and the majority of that, as mentioned, is food, with a significant contributions of things like plastics, consumable goods, and just generalized unrecognizable trash. And how those waste vectors are disposed of is represented in the graph on the right. And although it seems like there is a lot of decomposition here, it's worth noting that the 3 sections on the bottom, the sort of light blue, medium blue, and green, that's an open dump, a sanitary landfill, and a regular landfill. So in actual fact, we have something like 70% of waste that is just being put into some sort of landfill. And that obviously creates enormous emissions on site from decomposition of refuse, and creates a lot of methane and other gases. But it's also worth considering the process of getting that waste to landfill. So obviously, if most of the waste produced in the UK, for example, where I live, is going to places like Turkey or Southeast Asia, and the emissions journey, therefore, is not, or the emissions of landfill waste is inclusive of also an emissions journey. The graph here on the right is demonstrating which countries in the world generate the most municipal waste, and the US is really topping all of these lists. We love to be number 1 in the US, even for so many bad things. And the graph on the left is waste disposal vectors in different European countries. So the use of incineration of garbage is relatively high in Northern Europe, for example, and virtually unheard of in parts of the Balkans, but a really significant disparity in how waste is treated. And any of these, be it landfill or incineration or recycling, can be done more or less responsibly, but giving a broad stroke on how municipal waste is disposed of there are many different options for it. Although with regard to water, the graph on the left is about essentially the destination of how water is used on a global scale, and notably 2/3 of it is used for agriculture, which is part of why the emissions profile of agriculture is so significant, which we'll get to next. And in the US, as an example, a huge amount is used for power generation, which is true in lots of countries that have large scale energy production facilities that need, well, water cooling and where water is used as a generation source. So some useful facts about how those vectors bear out in water. And then the relationship between urban areas and water. It's notable that water consumption in rural areas is relatively low per capita, and it's slightly higher in urban areas per capita. The real culprit from a water efficiency perspective is suburban areas, and so lower urbanized areas but at low population density being suburban, and water consumption per capita is highest there, demonstrated through lots of research, as evidenced in the quotes on the bottom, and that's largely because of a larger footprint of homes and sort of economic and spatial policy in suburban areas. Okay, the final components of food systems and green space, I'm just going to smoosh together. The green space is a really essential component to talk about climate in cities, because nature is a natural carbon sink. The value of nature is well manifold. The value of different ecosystems in terms of storing and capturing carbon is second to none. And this graph shows the relative performance of different types of ecosystems. So wetlands being the most effective at storing carbon overall, and that's predominantly in the soil constitution, and these other ecosystems having their own relative performance. But green space is also useful for promoting, I would say, like social or behavioral, having positive social and behavioral externalities. So the use of nature as temperature regulator, for example, is well documented. These photos these images are from Sydney, and it's looking at the heat. It's a thermal image of a neighborhood in Sydney. Having green space and nature infused in urban areas reduces the urban heat island effect and reduces the need reduces the amount of cooling that can be required, and also can have significant health and both physical and mental health benefits. So having a temperature regulator through green space is really important. And then a note about distribution of green space. This research, which is from the World Bank, identifies that lower and middle income cities actually have more green than wealthier cities, and smaller cities have more than large cities, which I think is quite interesting, and is partly, I think, because of smaller and lower income cities having more integrated land uses and having more urban agriculture, a bit more, maybe less, fewer permeable surfaces. Many of us have probably been to cities that appear to be better, sort of have more present nature, and they're maybe less regularized, less suburbanized. So food systems are a huge contributor to global emissions, and it's relevant for cities because cities are the aggregator of the most of the people who consume the food in those systems. So this graph on the right is New Zealand's greenhouse gas emissions. New Zealand's GHG inventory demonstrates that agriculture is the single largest contributor in their context, and it's exemplary of why the different constituent parts are very relevant in urbanized countries similar to New Zealand. Dairy cattle being the single largest contributor, mostly of methane to their GHG profile, and that's because of the graph on the left, which is identifying the sources of methane, and enteric fermentation, which is the byproduct of biological processes inside of farm animals like cattle, are producing tons of methane. So the food consumption habits of urban dwellers is really driving the emissions of these emission sectors. And the part of the reason this is important from a sort of a broad climate perspective is that land use allocation really reflects the food system requirements that are demanded by consumers who again are mostly in cities. So this image is a picture of the UK if its land territory was divided proportionally, so aggregated together and divided proportionally. So all of the beef and lamb pastures smooshed together would be that green section in the middle that constitutes the majority of the land area. So all of the built up area in the UK would fit roughly into Wales, and all of the golf courses would fit roughly into whatever that island is in the northeast corner. So the takeaway here is just that we dedicate enormous amount of land and resources to animal husbandry in particular, and both the inefficiency of that and also the sort of opportunity cost intrinsic in that land use allocation is a challenge. The agricultural emissions are, so these are sort of factoids backing up my previous comments. So 57% of the world is urban, and 70% of food production is destined for urban areas. So the way that urbanites choose to consume is extremely important. And then I'll get into the well, I think I should move a little bit quickly because I'm moving too slowly. So this is essentially demonstrating the different food consumption habits in different countries and the relative carbon intensity of those foods. So the urbanites in Brazil are creating a lot more emissions from food than urbanites in India, for example. So I'm just going to speed through a couple of points on cities and climate before I hand off to Miodrag. The points that I wanted to make here were just that there's a diversity of ways to set priorities for how to address urban climate emissions. One common one is about spatial orientation. Fun fact is that Barcelona and Atlanta are roughly the same population, but Atlanta is roughly 10 times the size in terms of built-up area. And there are many conclusions there are many competing priorities about what is the ideal sort of lowest carbon urban development. And happy to chat with any of you about what we think is best. There's a lot of research that says that compactness rather than high density is best. And from a financing perspective, this is just to point out that municipal finance is a huge challenge, and this is why climate finance in the areas that ECO specializes in is so critical, because the very clear minority of cities in huge countries like Nigeria, Brazil, and India have municipal credit ratings and are able to raise their own finance. So that takes me to some of the solution, which is about climate technology. There need to be investments in both behavior change and infrastructures that are sort of technical innovations to reduce emissions in cities for all the reasons and in all the vectors that I've mentioned. And a lot of these are really, really sticky, really complex issues. This graph, the dark blue, represents essentially the hardest things to decarbonize. So important in that list is decarbonizing the building sector. And that's why we have my colleague Miodrag to talk with more specificity about how ECO does that. So with that, thank you very much. This is my email. Feel free to contact me, and happy to chat more about this in subsequent time.
Fantastic. Thank you, David. Really appreciate that. I love it when someone says, I get really excited about transportation systems. We all have our little things, but these sorts of ones really work for me. I love it. And thank you very much. We have got a question from Jack Steiber, but I'm going to, just in the interest of time, move ahead with Miodrag's presentation first. And then we'll try and come back to some Q&A at the end. With without doubt, we will send some written responses if we don't manage to get through to questions, or we don't manage to address your questions. So, Jack, very grateful. Thanks for posting the question. We'll get to it just now. So Miodrag Grujić is a member of our team with a background in cities. He worked for many years within the field of energy, climate change, and environmental protection. 16 years in the city administration of the city of Belgrade. He's led dozens of projects related to implementing energy efficiency in buildings, renewable energy sources, district heating, natural gas, projects with an international focus, collaborating with many of the well-known financial institutions such as EBRD, and other organizations like UNEP, GIZ, WRI, such like. So after working in that public sector, we're really privileged and honored to have you as a valued member of our team, Miodrag. You've started working with us as an expert, well, actually before joining ECO, as an expert on international projects with UNEP, Mott MacDonald, and now with ECO. I'm going to hand straight over to you, Miodrag. Take it away. Thank you.
Thank you, Grant. I'm very honored to hear these words. Maybe I'm not aware enough. Hello, everyone. I'm Miodrag Grujić. As Grant said, I'm an engineer from the company ECO Limited, and I'm based in Belgrade. ECO is based in UK. I'm based in Belgrade, and I deal primarily with energy efficiency and other climate mitigation aspects. And today I will present you some aspects of digitalization in buildings, which application should improve energy efficiency, heating and cooling, and some other aspects you will see later. Our company, the team consisted of our company and the German Dornier Group, worked on one very comprehensive digitalization project for the EBRD. And so many conclusions are taken from that project. Okay. Firstly, a few words about the current global position of and the importance of digitalization. Today, all sectors are connected to digitalization around the world. And that's why some international financial institutions and other international organizations, developing agencies, recognize that importance and significance, and adopted digitalization policies in their strategies for the coming period, and especially in developing countries. And I can say, how does digitalization work? Well, combining digital and physical infrastructure creates a smart infrastructure in which connected digital devices communicate with each other to efficiently manage infrastructure and services. I would like to say here a few words about our project, about our assignment. Our assignment was focused on buildings in terms of energy efficiency, heating, cooling, but also on some other aspects: security, mobility, lighting in buildings. When I say mobility, I mean of electric vehicle, two aspects. First of all, electric vehicle charging management and parking management technologies in buildings. You will see some pictures later, so that will be clear. Then, if we talk about buildings, we must include different types of buildings, especially public buildings, residential and commercial buildings. And for residential buildings, I mean of two main types: multi-apartment buildings and single-family houses. All these types are included in our consideration. Also, apart from heating, cooling, and lighting, I mentioned some other aspects are including, for example, metering and billing, heat metering and billing, and some technologies, some applications that can be useful for better communication with the customers, like demand-side response technologies and some others. And the main conclusion from this assignment, one of main conclusions, is that the building sector and the infrastructure sector, they're a bit behind compared to other sectors in terms of digitalization. So we can say that there is there is great space for improvement, for investment in digitalization in buildings. Now, a few words about benefits of digitalization. I grouped them here into 4 groups. The first one is financial group of benefits. Of course, digitalization is very similar. Effects of digitalization are very similar to energy efficiency. We have reduced costs, then higher profits because of reduced costs. And digitalized building, smart building, its property value is much higher than some simple building. As for another group, energy or environmental group of benefits, it's very clear. Digitalization in buildings provides reduction in energy consumption and consequently lower GHG emissions and emissions of pollutants as well. Then the third group is related to optimization of processes. Digitalization provides better productivity, efficiency, and management of few functions. For example, asset management, human resources management, other resources, finance management, vehicle and supply management in buildings and organizations, companies that use buildings. And the last group of benefits is related to people, various groups of people, users, consumers, employees. For them, digitalization enables better security, resilient buildings, better comfort, easier work for employees, better satisfaction, feeling safe, quality of service, and better communication with customers. On this slide, I would like to mention 3 main results of our project. The first one and the biggest and the main product is roadmaps, actually 9 roadmaps for digital transformation in 9 sectors. When I say 9 sectors, they're actually whole this story is divided into 2 groups. The first one is at the building level, and the second is on the energy generation and distribution level. But here I will be focused only on the building level. And there are 4 roadmaps related to the building level. Actually, what does it mean? One group is related to commercial and public buildings. The next one is multi-apartment buildings, then single-family houses, and the last one is mobility, actually parking management and electric vehicle charging management in buildings, in garage. And the second main result is digital compendium. You will see later the roadmaps and digital compendium are very connected. Digital compendium is a group of 44 digital technologies, including their descriptions and all detailed information for each technology. And the last result that I'm proud of that, because it was additional request from our client, is a digital tool intended to assess justification of investment in terms of digital transformation. Very simply, to assess if some potential investment is digital enough. Now I'm moving to digital roadmaps. I will say a few words about that. And as I mentioned, the digital roadmaps and compendium, there is a big and very important interconnection between them. A few words about roadmaps. Their intention is to foster the transition to a higher digital maturity level. We set a scale of digital maturity levels from 1 to 5, and the content of each roadmap consists of some subsections for benefits, challenges, key performance indicators, which is very important, and steps and actions to achieve a higher level of digital maturity. Then some cybersecurity considerations, role of public sector, private sector, and international financial institutions, and some case studies as good examples how digitalization can be useful and applied, and practical effects of digitalization in smart buildings. Digital compendium is, as I said, a group of 44 described technologies. It's a descriptive summary of relevant technologies, providing details needed to make decision on the inclusion of the identified technology in projects. And also, digital compendium serves to illustrate the main features, benefits, barriers, function, readiness, costs of each digital solution, and some other aspects like standards, solution providers, circular economy, and etc., etc. And now this is my favorite slide always when I talk about digitalization. This German Shepherd is a good example how for moving to the next digital maturity level, he's probably ready for digitalization and digital transformation. And this picture can show us if we are focused and dedicated and interested in something, there is no too high barrier. And okay, I can come back to the left part of this slide. Main challenges identified in this project are the initial costs might be high for many building management of buildings and companies, organization. Lack of transformation strategy or understanding of responsibility of building management. Then the high energy consumption is often not noticed, or there is no good or quality enough data about the energy consumption. And then the last two challenges are related to some people's habit, I would say. Sudden change in the way of functioning is a risk for which some companies are not ready. And resistance, some people from management of companies are resistant to new tools, processes, skills, technologies, and security issues. I'm focused on developing countries, so that's why maybe these reasons exist. Now a few words about key performance indicators for assessment of digital maturity levels. On the right part of this slide, you can see different types of buildings that can be digitalized. For example, supermarkets, hotels, business buildings, airports, residential buildings, skyscrapers, sports centers, university, etc. KPIs, there are more than 10 KPIs, but I grouped them here into a few groups in order to explain easier. KPIs are related to the level of digital awareness of management of some company, for example, building management. Then digitalization of various functions, for example, HR management, financial management, vehicles and supply management. Then digitalization of work tasks, asset management, remote management, use of operational data for processes optimization, cybersecurity issues, communication with customers, and potential leadership in application of digital technologies or models. A few words about actions to the next digital maturity level. Key actions for moving to the next level from 1 to 5 can be related to some groups as follows. People, data and cybersecurity, process and technology, then regulatory, institutional, financial, and legal barriers or issues, and creating opportunities. But the most important highlight here is this line on the right, and explanation for that is that progress between different maturity levels is not always linear nor equally challenging, so patience is very important. Now, a few examples to see practical application of this project and of digitalization in general. You can see one garage with very expensive cars and two aspects of mobility in smart mobility in buildings. On the wall, you can see electric vehicle chargers, and also you can see here parking management. Two aspects of mobility, smart mobility in buildings. On the picture below, you can see dimmable lighting and digital blinds and a few more digital solutions in one smart home in Czech Republic. And on the left side, it's maybe the best example. You can see one screen on one mobile phone. There are two screens. This application consists of two screens. It's in Polish, but doesn't matter. You can see everything. You can see icons and explanation for it. You can manage all functions in one smart home by your mobile phone. For example, you can see weather forecast, heating, cooling, lighting, cameras, I don't know, music. Everything is connected and can be used can be managed by your mobile phone. And now something about role of various stakeholders. It's very important role of the public sector in every country. Expectations from the public sector is to develop regulatory framework for digitalization, for encouraging digitalization, and public procurements should include digitalization in a similar way as the energy efficiency. Then it's very important to establish a guarantee mechanism for financing digitalization, also similarly to energy efficiency, especially in multi-apartment buildings especially if some building consists of people with very different life standard. Public sector and public buildings managers should be the first movers for digitalization, and also central government should support the development of the digital market, and the role of the public sector is changing the mindset of people. The private sector should be included through different roles. For example, technology providers are private sector. Then private sector can help with the research, development, and practical application of digital solutions. Also, management and implementation of solutions can be provided by private companies. And banks, in terms of commercial banks, can support the inclusion of digitalization into specific lending products. And also end users are private sector. IFIs, international financial institutions, and the other funds, let's say, should cooperate with the public sector and governments on addressing barriers, also to provide financial support to governments. And a good example is forming banking teams for digitalization, like At SIG, it's name of the banking, let's say digital banking team in the EBRD, but some other institutions also has some digital teams for development of digitalization. And the last thing, as I said, I'm very proud of it. A few words about digital tool. Purpose of the digital tool is to to assess digital maturity, potential improvement of one building by application of some digital investment. Then to evaluate the feasibility of investing in a building, and to identify opportunities to implement digital technologies from the compendium. But let's say it in a simpler way. The investment decision requires three aspects. The first one is improve digital maturity in terms of if the assessment, if this potential investment is digital enough. Then the financial aspect is included through the payback period. There is some threshold, and that should be met. And the last one is the energy efficiency. Also, there is some threshold. So there are some options. In one option, all three conditions must be met to have justified investment. And there is some other options. Maybe one or two of these conditions are enough for justification of any investment. Now that's it. Now we can discuss questions and answers. Thank you for your participation, and this is my email and the website of ECO. So now it's time for discussion.
Fantastic. Thank you very much, Miodrag. Really appreciate it. One of the big challenges is definitely how to deploy these sometimes really complicated. It comes down to a people thing. You talked about the challenges there, Miodrag. It does come down to a people's thing because they can be exceptionally complicated. I'm based in London, like David, and I've been trying to get my smart meter working for more than a year now, and it's just so strange. It should all work smoothly. It's digital, yet it takes months to even connect the meters. Anyway, it can be done wrongly, I guess, is the point that I'm trying to make, and those challenges are extremely real ones that you highlighted. So thanks a lot. We do have a question from Jack. This is related to David's presentation. I'm planning to continue. We'll bring the webinar to an end. I know some people have had to jump off onto other calls and such like, but we're recording it. We'll bring the webinar to an end at 1:20. So we've got a little bit of time to have questions. And I think last time I checked, Jack was still in the call. So it would be great to address that one. Shall we do that? Yeah. So Jack has written, have you observed a significant increase in urban forestry initiatives, in carbon reduction initiatives, investments, as not only a climate adaptation strategy, but also for community provisioning, gardening, food, and such like?
Yeah, it's a good question. I think from my experience or my vantage point, I haven't seen a huge uptick in urban forestry so much as carbon reduction infrastructure. So sort of the latter, but not the former. I think the preponderance of sort of carbon storage or carbon reduction investments that we see on an urban scale are focused on carbon offsets, which has its own which is a deeper conversation about the sort of efficacy and ethics of carbon offsets in general. But I know in the UK, for example, a lot of urban development projects are offsetting with big urban forestry or urban reforestation projects in different parts of the world, both domestic and international. So I do think there's an increased awareness of and investment in sort of green infrastructure as part of urban development. And in terms of community provisioning gardens and food, I do think that is still common. I think it's slightly different than the former, but the initiatives, I haven't seen a lot at sort of sufficient scale in urban agriculture. I think the largest urban farm in the world has just been built outside of Paris. So there are investments happening, but in terms of sort of significant increases in number of places, I don't see it happening quite as much as you might expect.
I was very struck by those images you gave, David, of it was from Australia, where, you know, depending on the green space around residential, commercial roads and such, like the, you know, I guess the urban heat island question, it's a heating issue, which I suppose, you know, when I get up in the morning, I can see around me. I look at a map on my phone, which shows me that because there's a forest very close to me, it has an impact on the temperature here in my home. And I guess in very hot countries, this is, you know, a contributor to the air conditioning. So it's both, as Jack has said, a climate adaptation strategy, but there's a mitigation side that is not through carbon storage, but actually by reducing the need for cooling, I suppose. I don't know how strongly that link is there.
Yeah, no, it is areas of cities that have you know, significantly high proportional tree coverage do have lower cooling bills. And it actually provokes an interesting equity question as well, because the parts of cities that are often equipped with more green space are often the more desirable places to live. So there's a socioeconomic equity question about places that have more green space might require lower energy bills from residents.
Yeah, indeed. Yeah, thank you very much for that. Miodrag, can you say something more about those deployment challenges? I know your study was specifically in the region, including North Africa and such like. We got an example from David of Jakarta. I mean, what do you see as the primary challenges related to deployment of some of these digitalization technologies?
Yes, this assignment is related to all 38 countries of operations of the EBRD. So it's Eastern Europe, Western Balkans, Central Asia, and MENA region. And some challenges are common and some other challenges are specific. But in general, the main challenge and barrier is a level of awareness and resistance to apply digital solutions in buildings. And I can say some of these reasons are justified because some solutions require initial costs can be high, but one good analyze, let's say cost effective, or I don't know, financial analysis should show effects of digitalization in a few years. But these effects are not only related to the financial side. They are more they're wider than financial side. They also include the social welfare, happiness of people, better quality of the air, less climate change, I would say.
Yeah.
And they're very comprehensive.
Yeah, and that brings us to Hugo's Osterkamp's question here around the balance digital technologies and urban CO2. Maybe just a quick word from you, Miodrag, and from David. I mean, do we have data or knowledge on that? It's something we need to research too. I mean, is it worth accelerating that shift to digital to address urban CO2?
David.
Start off, David.
You're muted.
Yeah, I was going to say I don't know is the short answer.
Okay.
I haven't seen evidence overlaying the sort of degree of digitalization and CO2 emissions, for example. But I think we can look at the sort of use effectiveness of digitalization investments specifically, which Miodrag would probably know more about. So you can say relative to the same neighborhood or the same building relative to its previous performance is performing better or worse in terms of emissions.
I can add one example just from my city, but it's one good example from a new settlement. That technology can be called demand side response. Tenants in one settlement in a few buildings have an opportunity to follow their energy consumption, heating consumption, and they have a good application, and they can reduce. They have also technical preconditions and solutions for that in terms of heat cost, locators, valves, and they can reduce their consumption, and in that way they can help the heating plant to plan its needs for fuel, and it's one very good example of communication between users and heating plant, and that way they also can users also can reduce their cost for energy. So that application is very, very helpful, and it's applied in Belgrade, but in a few settlements, or in a few buildings in one big settlement. But it's a good example that should be applied in many buildings. There are good examples from Denmark, from some very developed countries, but also I'm talking about these countries of operation.
Yeah. Thank you very much, Miodrag. Thank you, David. We've got a great question from Fiorella. Unfortunately, we don't have time to address that, but it's something that we're extremely interested in how you foster this private and public sector, and specifically digitalization in developing countries. We will put in some thoughts in the replay kit, which we will provide. We really do say a huge thank you for attending. It's been wonderful to hear these great presentations from David. Thank you, Miodrag. Thank you very much. The good questions people have asked, really appreciate that. And the participation, you know the word I'm trying to say, involvement in the polls, that's really been appreciated. Lovely to see you all here. Thank you for taking time out of your day. Please do contact us. Our emails are there, or you can reply when you get the replay kit. So all people who registered for this will receive that replay kit and further communications. Of course, you can opt out of that at any time. Yeah, I think that's it for now. Please do visit our website, connect with us, LinkedIn, Twitter. If you have any further questions on the webinar or help with project you're working with, get in touch with us. That would be really great. And we'll see you at the next webinar, dealing with this sort of training-oriented Eco-Institute webinar, but we also run webinars related to some of the funds, most notably the Green Climate Fund, board meetings and such. Like, if that's interesting to you, keep an eye out for that. Thank you very much. Really appreciate all that.
Thanks, everyone.
Thank you.
Thank you.